All right, welcome back. We are talking about forms of linear equations. So far we've looked at slope-intercept and point-slope form. Recall slope-intercept gives you the slope and the y-coordinate of the y-intercept. So if you have those two pieces of information, you can create an equation for the line. Point-slope gives you an equation of a line if you know the coordinates of one point and the slope. And lastly, we're going to look at standard form. Now, standard form, unlike these other two, does not have the slope or a point coordinate built directly into it. It is a form that is easy to find x-intercept and y-intercept from, and it's not too hard to find the slope from it. But part of the purpose of learning standard form is because other equations that aren't for lines but are for curves like parabolas or ellipses, circles, sinusoidal functions, all those crazy curved things, they have standard forms too, and there'll be a relationship between this standard form and those other standard forms down the road. That won't be the topic of today's video, but I wanted you to know that in the world of math, there's a reason, there are reasons for having the standard form. Now, we're going to look at what the standard form is in this video. That's the scope of this video. Okay, so I will hand you this one. It goes like this. A times x plus b times y equals c, where a, b, and c are all constants. They're numbers that don't change. X is a variable, y is a variable. They could be anything, but a, b, and c are going to be particular numbers. Okay, here's an example. 2x minus 3y equals 4. Here's a linear equation. As x changes, y will change at a constant rate. That's why it's a linear equation. We'll look at that some more in a moment. Let me point out some of the things that make this a standard form. Those constants are not only constant, they don't change. 2, negative 3, and 4 don't change from 2, negative 3, and 4, but they are also integers, okay? They are not fractions, they're not parts of a whole, they are complete wholes. So this equation, 1/2 x plus y equals negative 2, that's not in standard form because this constant, although it doesn't change, isn't an integer. It has to be an integer, or a whole number, in order to be in standard form. Okay? So, this is not okay. We'll get rid of that. Keep with our example. Now, if we wanted, so we'll write that. A, B, and C are integers. Now, mathematicians vary on what they claim has to be the case here or not. Some of them will tell you that the x term should be positive. I think that's a good idea. It's not required or necessary, but it's a good habit. It simplifies some things if you always write this expression so that x has a positive coefficient. So I'm going to put that a is greater than 0. A is positive. Okay? So a, b, and c are integers, and a is greater than 0 are stipulations for having this be standard form. All right. So let's see what happens if we want to graph this. How do you graph a line? You need to know a couple points on the line. Well, you could pick any x and y value you want. Pick an x value, solve for y, and figure out what the y is. That's one way to go. But you can make your life easy. Don't just pick anything. Pick something that makes things simple. Well, if x is 0, then 2 times 0 is nothing, and that makes solving the equation simple. So let's say x is 0. What would y have to be? Well, this is 0 minus 3y equals 4. Solving for y, we would undo the multiplication. So instead of multiplying by 3, negative 3, we divide by negative 3 on both sides of the equation. That gives us y equals 4 divided by negative 3, or negative 4 thirds. Okay. Same process, only we're going to figure out what happens when y is 0. That's easy, because then this term becomes nothing, and we end up with 2x equals 4 when y is 0. And if we divide by 2, we are left with x equals 4 divided by 2 is 2. And now I've got 2 different points on my line, but they're special points. They're points where the x-coordinate is 0 or the y-coordinate is 0. So this point, when x is 0, you're on the y-axis. Let's make that. We've got the x-axis and the y-axis. We know we have a point when x is 0, we're somewhere on the y-axis. It's negative 4 thirds, so that would be if this is 1, 2, then that's right about there. 0, comma, negative 4 thirds. And then we're at a point, 1, 2, and our y-coordinate is 0. That's on the x-axis. Okay, so that's cool, because those are not just any point, those are points on our axes, and I can connect the dots now and make my line. It's going to look like this. Goes through those 2 points that I know. If I wanted to, I could figure out the slope. Let's do that. If we wanted the slope, look at our other 2 forms. Both of these have the slope built into it. And this one uses the y-intercept as part of it, and this one uses any point, so we could use either of those points in there, okay? But in order to find slope of anything, if you know 2 points, which we do, we can find it using this equation right here. The slope is the change in y, y2 minus y1, that's 0. So change in y equals 0, minus this one, negative 4 thirds. And then the change in x in our denominator is 2 minus 0. And the result is, well, 0 minus a negative is addition, so we have 4 thirds. And we're dividing 4 thirds by 2 minus 0 is 2. Now that's a complex fraction, so we should simplify it. So this is equal to 4 thirds divided by 2, or 4 divided by 2 times 3, which is 2 thirds. And all of that stuff is our slope, right? So our slope is 2 thirds. M is 2 thirds. Now, we could do that in general as well, and we'll do that on the next video.